Thanks for watching my video. Today let's discuss some application of Rolle'S theorem. Okay. Here our question says that prove that if a0, a1, a2 up to an are real numbers such that a0 over n plus 1 into x to the n plus 1 plus a1 by n into x to the n plus and so on plus a n x is equal to 0, then there exists at least one number x between 0 and 1 such that a0 x to the n plus a1 x to the n minus 1 plus and so on plus an is equal to 0. From here we are going to prove this one. Okay, let's rewrite our equation. A0 over n plus 1 x to the n plus 1 plus a1 over n x to the n plus and so on plus a n x is equal to 0. And let's code this to be equation 1. Now let f of x to be this one, which is a0 over n plus 1 x to the n plus 1 plus a1 over n x to the n plus n, okay, n plus and so on plus, let me write here one term, a n minus 1 over 2x square plus a n x, okay, such that x belongs to close interval 0 and 1. Let's say this to be equation 2. Now since f is a polynomial in x, okay, therefore since this or f of x is a polynomial function, so you should know that every polynomial function is a continuous, okay. That means f is continuous on closed interval 1 and 0 and 1, and it is also derivable on open interval 0 and 1. This is 0 and 1, okay. And number 3, f of 0 is equal to f of 1, since f of 0 is equal to 0, because if you put here f of 0 here, if you put in place of x 0 0 0 and 0, this will be 0, and f of 1 is 0, well, because in question 1 if you put f of x is this one, if you put x to be 1, then all this term is equal to 0, okay. Then is from 1 and 2, equation 1 and 2. This is from equation 1 and 2 you get. Now that means our Rolle'S theorem is satisfied, okay. So our Rolle'S theorem is satisfied now. What Rolle'S theorem stated, if a function satisfy all this, then there exists some number which x belongs to open interval 0 and 1 such that f prime of x is equal to 0. Now therefore f of x is what? This one. If you take the differentiation, what you will get a naught n plus 1 over n plus 1 x to the n plus a1 n over n x to the n minus 1 plus and so on plus a n minus 1 into 2 over 2 into x plus a n, which is equal to 0, okay, this one. Now cancellation take place, a naught x to the n plus a1 x to the n minus 1 plus and so on plus a n minus 1 x plus an is equal to 0. So which is our proof? Okay, this one. So hence proof.